To go to the moon would cost perhaps $1,500 $3,000 per pound. Based on current commercial launch capabilities like SpaceX's Falcon Heavy and NASA's Artemis program estimates for lunar missions. In a startling and deeply captivating hypothetical scenario, renowned theoretical physicist Michio Kaku stunned the scientific world by presenting a speculative theory that radically redefines humanity's understanding of the moon. Known for pushing the boundaries of conventional science, Kaku offered a perspective so bold and provocative that it stirred immediate global intrigue. Rather than adhering to the long-held notion that the moon is a simple natural satellite formed through an impact event, he proposed a paradigm-shifting view that suggests the moon might be more complex, more engineered, and more enigmatic than previously believed. The implications of his statements have sent ripples across not only the astrophysics community, but also among those who have long suspected there is more to Earth's celestial companion than meets the eye. Please consider liking and subscribing for more updates. Kaku's presentation was grounded in his deep knowledge of quantum theory, cosmology, and advanced physics. Yet he delivered it in a way that reached beyond academia. With clarity and an air of deliberate caution, he began by re-examining the origins of the moon. The commonly accepted theory, the giant impact hypothesis, suggests that a Mars-sized body collided with Earth billions of years ago, and the resulting debris eventually coalesced to form the moon. However, Kaku challenged the simplicity of this theory by drawing attention to numerous inconsistencies and anomalies that mainstream science has struggled to explain. For instance, he highlighted the moon's orbital precision, its unique geochemical composition, and the sheer improbability of its current position and size relative to Earth. He emphasized that the moon is disproportionately large compared to Earth when considering other planet-moon systems in our solar system. Its orbit is almost perfectly circular, and its synchronization with Earth results in the same side always facing us, a phenomenon called tidal locking. These features, while not impossible in nature, are extraordinarily rare. Kaku suggested that they appear almost too perfect to calculated to be purely coincidental. This opened the door to a more controversial idea that the moon may not be a wholly natural object, but rather the product of advanced design. The core of his argument rested on the notion that the moon's properties seem engineered to support life on Earth. He pointed to the role the moon plays in stabilizing Earth's axial tilt, thereby moderating the planet's climate and making it hospitable for complex life. The moon's influence on tidal systems is also essential, affecting ocean currents and ecological cycles. Kaku argued that these factors are too finely tuned to dismiss as random, especially considering the moon's composition, which, upon closer examination, does not fully align with Earth's mantle. This discrepancy raises significant questions about the moon's true origins. Digging deeper, Kaku explored the internal structure of the moon. Seismic data from instruments left behind by the Apollo missions have shown that the moon rings like a bell when struck by meteoroids, a phenomenon interpreted by some researchers as evidence of an unusually low density or cavernous internal structure. Kaku addressed this data not with sensationalism, but with scientific curiosity. He proposed that the moon might possess massive voids or even metallic elements within, raising speculation about artificiality. While he did not claim definitively that the moon is a construct, he insisted that the data warrants further exploration, suggesting that what humanity has long regarded as a dead, barren satellite might instead be an artifact of immense age and mystery. One of the most compelling aspects of Kaku's revelation involved gravitational anomalies on the moon's surface. There are regions where gravity behaves irregularly, where spacecraft experience slight shifts in acceleration without apparent cause. These maskings, or mass concentrations, suggest buried structures or formations of unknown origin, while conventional science attributes these to denser rock formations beneath the crust. Kaku speculated that alternative explanations could involve artificial installations or remnants of something far older than human civilization. If these anomalies are evidence of some ancient intervention, it could mean the moon holds relics or even data from a bygone era, or an extraterrestrial intelligence. This suggestion led to an even more controversial implication that the moon might not only be unnatural, but intentionally placed. Kaku proposed that the possibility of the moon being a deliberately positioned object should not be dismissed outright. He considered the idea that an advanced civilization, potentially millions or even billions of years ahead of humanity, could have engineered such a structure either as a monitoring station, a beacon, or a stabilizing mechanism to foster life on Earth. The Moon's age, as determined by some lunar rocks, appears to be approximately 4.5 billion years, similar to Earth's, challenging earlier claims of it being older. Kaku's unveiling of this hypothesis was not just about speculative theory. It was a challenge to current scientific orthodoxy. He called for a re-evaluation of existing lunar data. With open-mindedness and technological advancement, he urged the scientific community to approach the Moon, not just as a relic of the solar system's chaotic birth, but as a possible repository of untapped knowledge, perhaps even intentional design. In Kaku's eyes, the Moon might serve as a cosmic Rosetta Stone, waiting to unlock secrets about the nature of life, the universe, and our place within it. Another layer to his revelation dealt with the unexplained electromagnetic phenomena observed around the Moon. Several space missions, both manned and unmanned, have recorded inexplicable bursts of radiation, anomalies in communication, and mysterious lights, often referred to as transient lunar phenomena, though traditionally dismissed as optical illusions or instrument glitches. Kaku emphasized that the recurrence and consistency of these observations deserve more than cursory explanations. He hinted that these could be signatures of energy sources or mechanisms embedded beneath the lunar surface, again pointing to artificiality or purposeful design. Moreover, Kaku discussed the Moon's almost eerie alignment with the Sun. During a total solar eclipse, the Moon perfectly covers the Sun's disk as viewed from Earth. Despite the vast difference in their sizes and distances, this coincidence, while known, is a rare occurrence among celestial bodies and contributes to a growing sense of the Moon's peculiarity. K18 hours 31 minutes and 31 seconds. Kaku did not present this as definitive evidence of intelligent design, but rather as another layer of mystery, another strange coincidence in a long list that, when viewed together, begins to form a picture that defies conventional randomness. He also touched on ancient texts and myths from various civilizations that describe the Moon appearing suddenly in the sky or being brought into existence. While Kaku remained grounded in science, he acknowledged that these ancient narratives might hold fragments of historical memory, worth examining through the lens of modern research. These stories often describe the Moon as a newcomer to the sky, a fact that contradicts the scientific model that the Moon has orbited Earth for billions of years. Could these myths be allegorical, or are they distorted memories of a time before the Moon was in its current orbit? What makes Kaku's revelation especially gripping is the fusion of hard science with the audacity to question fundamental assumptions. He did not present his views as absolute truths, but rather as provocations, an intellectual invitation to think beyond traditional frameworks. His insistence on rigorous data analysis, combined with a willingness to entertain high-risk hypotheses, represents a shift in scientific discourse. It is a call to explore not just what is probable, but what is possible. The Moon, long considered a passive, lifeless rock, suddenly becomes a subject of potential intentionality, structure, and purpose. Kaku's ideas also ignite a broader philosophical conversation. If the Moon were found to be artificial or even partially constructed, it would force a re-evaluation of human history and identity. It would imply the existence of intelligent beings capable of interstellar engineering, beings who either influenced or observed the development of life on Earth. This could revolutionize everything from evolutionary biology to theology. Wow. Kaku avoided veering into speculative spirituality. The implications of his statements reverberated into metaphysical realms, inviting contemplation on a cosmic scale. The Moon's proximity and visibility have made it a constant presence in human consciousness, yet its mysteries remain surprisingly deep. Kaku's daring exploration into these mysteries has shaken the scientific status quo, not by offering definitive answers, but by exposing the questions that have been too long ignored or trivialized, by reframing the Moon not as a passive element, a verse system, but as a possible key player in humanity's development. He has recontextualized the satellite as something potentially vital, intentional, and extraordinary. His approach, blending scientific rigor with imaginative scope, offers a refreshing divergence from rigid empiricism. He showed that science need not fear the unknown, and that true discovery often begins where certainty ends. Whether or not the Moon turns out to be artificial, the pursuit of that possibility forces deeper scrutiny, better technology, and more holistic inquiry. It reawakens curiosity, an essential element in any genuine scientific endeavor. The mere act of proposing such a revolutionary idea does something profound. It shifts the cultural lens through which people view the universe. The moon is no longer just the backdrop of human romance, mythology, and exploration. It becomes an active, dynamic entity in the cosmic narrative. It may harbor secrets yet to be uncovered or even origins that predate known civilization, whether as an ancient satellite with curious anomalies or as something crafted with unimaginable precision. The moon, under Kaku's lens, becomes a puzzle of the highest order. Kaku concluded his presentation with a firm conviction that further lunar missions, both robotic and manned, must prioritize these unexplored questions. He advocated for drilling deep beneath the moon's crust, mapping gravitational inconsistencies with higher resolution, and developing instruments specifically designed to detect signs of artificial structure or non-natural materials. The moon, in his view, is no longer just a destination or a stepping stone for Mars. It is a mystery that may redefine what it means to be human in the vast context of the universe. Through this unprecedented revelation, Michio Kaku has not only challenged the foundational assumptions of planetary science, but also ignited a new era of curiosity about the moon. In doing so, he has reminded the world that sometimes the most familiar objects, though seen every night from every corner of the globe, may still hold the most profound secrets. The moon, long silent in the sky, now speaks through its strange, unaccountable features, and what it might be saying, as Kaku suggests, is that we have barely begun to understand its purpose, its origin, and its place in the cosmic design. Following Michio Kaku's extraordinary presentation, a profound shift in perception began to unfold. The moon, once regarded as a passive and familiar entity, suddenly loomed larger in the collective consciousness, not just in terms of physical size, but in its enigmatic presence. As Kaku delved deeper into the moon's intricacies, he transitioned from well-known facts to obscure findings and lesser-discussed features, many of which had remained largely unaddressed in mainstream discourse. He began weaving together a narrative that placed the moon not just as a component of Earth's astronomical environment, but potentially as a piece of a much larger cosmic architecture, revealing layers of complexity that challenge every assumption we've held about our natural satellite. One of the more obscure elements that Kaku brought into the conversation was the moon's orbital anomalies. Although its path around Earth appears predictable, tiny irregularities have been detected, imperceptible to the naked eye but measurable through precision instruments. These deviations from perfect Newtonian motion are often dismissed or downplayed. However, Kaku emphasized that such anomalies, though slight, suggest the presence of hidden dynamics at play, whether due to mass differentials beneath the lunar crust or other unexplained forces. These fluctuations could imply that the moon is not entirely governed by standard gravitational behavior. In his view, if deviations exist, they warrant more serious scrutiny and should not be chalked up to random variances or limitations in instrumentation. He went on to explore how the moon's reflective properties raised interesting questions about its surface material. Unlike most celestial bodies in the solar system, which scatter light in predictable patterns based on their composition, the moon reflects sunlight in ways that seem unusual. Some areas exhibit high albedo brightness levels that don't quite match up with the rock types collected during the Apollo missions. This irregularity suggests there may be unknown materials or surface treatments affecting the reflectivity. In fact, certain regions have remained unusually resistant to erosion, despite being bombarded for eons by solar radiation and micrometeorites. Kaku proposed that these high durability regions might be synthetic in origin, possibly remnants of coatings or layered structures beneath the regolith. Moreover, he highlighted the moon's electromagnetic signature as another point of fascination. Sensitive instruments have picked up low-frequency electromagnetic pulses coming from the lunar surface. These pulses are not entirely consistent with natural geological activity, such as moonquakes or thermal shifts. Some patterns resemble those found in artificially induced signals, structured in a way that hints at modulation. Though he made no definitive claims, Kaku raised the possibility that these could be remnants of past technologies or even ongoing processes occurring within the moon, undetected until now. The suggestion that such a simple-looking object might be quietly broadcasting or resonating with frequency patterns is a compelling deviation from classical lunar science. Another captivating thread in Kaku's discussion was the presence of symmetrical features on the moon's far side, while the near side, the hemisphere visible from Earth, shows familiar maria and craters. The far side has an oddly regular, almost geometric arrangement in certain basins. Craters positioned at unusually equidistant intervals, hexagonal depression patterns, and uncharacteristic symmetry in mountainous formations prompted him to question whether natural forces alone could explain such organization. He referenced data from lunar orbiters and imaging systems that recorded surface features in great detail, noting how some structures bear an uncanny resemblance to polygonal configurations. While geological symmetry isn't impossible, its recurrence on the hidden side of the moon raised questions that begged further analysis. Through higher resolution topographical studies, Kaku also examined the thermal behavior of the moon, particularly during lunar nights. With no atmosphere to insulate heat, temperatures drop to extreme lows, yet there are hot spots, areas that retain heat longer than they should. These thermally anomalous zones are not near known radioactive deposits or impact sites, leading to speculation that they could be associated with underground chambers, internal activity, or foreign materials. He emphasized that standard explanations, like rock density or regolith variation, fail to fully explain the extent of thermal retention in these zones. If these areas are indeed artificially insulated or structured in such a way as to retain warmth, the implications would be profound. A particularly bold section of Kaku's exploration involved deep lunar cavities. Several missions, including those by Japan's JAXA and NASA's Grail spacecraft, have discovered vertical shafts leading into vast underground voids. These formations, initially thought to be lava tubes, are immense, some large enough to house entire cities. Kaku pushed further, asking why so many of these tubes remain structurally intact, whereas Earth's similar formations tend to collapse over time. Could this be an indicator of reinforcement or internal stabilization? He even entertained the possibility that these chambers might have been excavated, rather than naturally formed, suggesting the presence of ancient engineering capabilities, whether for habitation, storage, or energy collection. The potential utility of these voids hints at intentional use, far beyond our current understanding of lunar geology. Attention then turned to an oft-overlooked detail, the moon's magnetic past. Today, the moon lacks a global magnetic field, but rock samples suggest it once possessed one, possibly as strong as Earth's. Kaku noted that for a body of the moon's size and composition, this magnetic strength is unexpected. He explored the idea that if the moon once had a core capable of generating a magnetic field, what caused it to stop? Or, more provocatively, was the magnetic field artificially created and then deactivated? The cessation of such a phenomenon could point to a controlled system rather than natural planetary evolution. It also raises the question of whether remnants of that system still exist deep within the moon's core, now dormant but detectable through magnetic anomaly mapping. Kaku further addressed the moon's apparent gravitational influence, not just on tides but on biological systems. Some species on Earth, including humans, show subtle physiological responses aligned with lunar cycles, phenomena not easily dismissed as mere superstition. He discussed studies showing correlations between lunar phases and patterns in sleep, reproductive behavior, and psychological fluctuations. Though traditionally attributed to cultural conditioning or coincidence, Kaku suggested a radical reconsideration. What if the moon was positioned or tuned in a way that directly interacts with Earth's biosphere at a deeper, possibly electromagnetic or quantum level? He even explored the possibility that the moon serves as a kind of natural or unnatural gateway between fields of energy. Some French physicists have speculated that lunar periges and eclipses coincide with surges in quantum fluctuation activity or gravitational lensing effects. Kaku, without endorsing French theories, acknowledged that gravitational resonance models still leave many unknowns. Could the moon's position create or modulate a kind of energy corridor or dimensional boundary, facilitating phenomena that traditional physics hasn't yet fully grasped? Another subject Kaku approached with rigorous curiosity was the age of the lunar dust. Compared to the rocks beneath it, lunar regolith appears to be significantly older than many of the rocks it covers. This inversion of natural layering poses a puzzle. If the moon formed via an impact and cooled over time, how did the dust, which should accumulate last, become older? Kaku suggested that the surface layer might not be of lunar origin at all. Could it have been deposited from an external source, possibly even from outside our solar system, or was it intentionally laid down, perhaps as a form of camouflage or environmental insulation? Then there's the issue of the moon's crater distribution. Kaku highlighted the statistical oddity that many craters are of similar depth, regardless of diameter, indicating a hard subsurface layer. Larger impacts should theoretically produce deeper craters, but this is not what we observe. He posed a hypothesis. What if the moon has a protective inner shell, like a hole, that prevents deeper penetration? Such a structure would be consistent with the theory of artificiality and could point to engineering on a planetary scale, possibly to preserve inner chambers or mechanisms. Kaku also turned to ancient astronomical alignments. Numerous megalithic structures across Earth, from Stonehenge to Nabta Playa, appear to be aligned not only with solar and stellar bodies, but also with the moon in incredibly precise ways. He raised the possibility that the moon has played a greater role in guiding human civilization than we currently acknowledge. Its predictable movement could have served as a timekeeping or navigation reference, but perhaps, even more intriguingly, it may have been deliberately used by an advanced culture to encode knowledge in terrestrial monuments. This segued into his brief but significant mention of lunar harmonics, the moon's orbital period, rotational period, and distance relationships with Earth and the Sun appeared to contain ratios closely aligned with Fibonacci sequences and other harmonic constants. While these could be natural byproducts of orbital mechanics, the repetition of such mathematical elegance suggested to Kaku a pattern worth studying further. He pointed out that nature does follow mathematics, but when that math begins to resemble intelligent encoding, it opens a window to a new kind of inquiry, one where engineering and astronomy blur. Furthermore, Kaku revisited the early space programs and the often unexplained behaviors of some lunar missions. He noted that several Apollo flights recorded unexplained instrument malfunctions and periods of radio silence, while NASA has publicly explained these as technical difficulties. The timing and locations of these interruptions had caused some to speculate about electromagnetic interference of unknown origin. Kaku did not promote conspiracy, but underscored that repeated anomalies in the same geographic regions should not be ignored, especially when modern equipment has confirmed peculiarities in those very locations. He also raised the point about the moon's potential as a long-term storage facility, not by humans, but by other intelligences, given its geological stability, lack of atmosphere, and low seismic activity. The moon would be an ideal location to store data, technology, or even biological material, if any civilization sought to preserve its knowledge or reach across time and space. Placing information in a stable, observable, but difficult-to-reach location like the moon would make strategic sense. Kaku encouraged a re-examination of the moon's surface and subsurface using advanced spectrometry and radar tomography to identify potential anomalous voids or unnatural regularities suggestive of buried technology. Kaku concluded his deep exploration by reminding his audience that human knowledge, however vast, still rests on a fragile foundation of assumption. The moon, ever visible in the sky and long assumed to be fully understood, may still be guarding its deepest truths. If even a portion of the anomalies he outlined point toward artificial origins or unknown physics, then our current scientific paradigm is incomplete at best and deeply flawed at worst. By stripping the moon of its veil of assumed normalcy, Michio Kaku has reshaped the boundaries of what can be questioned in science. He has not claimed that the moon is artificial, but that the weight of unusual data demands that we at least entertain the idea. In doing so, he has reminded the world that true discovery does not come from clinging to certainty, but from a relentless willingness to seek out what we do not yet understand. And perhaps the most astonishing part of it all is not just what we've overlooked in our observations of the moon, but what it says about our place in the universe. If the moon is more than a rock, if it has been shaped, positioned, or purposed, then so too might be Earth and humanity itself. Kaku's revelations transformed the moon from a passive fixture into an active question mark, a symbol of cosmic intent, mystery, and possibility. As Michio Kaku ventured further into the depths of his lunar revelations, he steered the discussion toward the possibility of the moon acting as a temporal bridge, an object whose role in Earth's history may extend not just across space, but across time in ways not yet fully understood. He introduced the concept of the moon not only as a physical presence, but as a silent witness to the eons, potentially containing within it records of cosmic events, solar activity, galactic radiation patterns, and even extraterrestrial interventions that span billions of years. The moon, lacking atmosphere and tectonic activity, preserves ancient imprints on its surface far better than Earth, which constantly renews itself. It could serve as a time capsule for both natural cosmic evolution and deliberate data deposition, placed by civilizations with foresight that far exceeds our own. Building on that, Kaku turned attention to the moon's orientation and positional fixity. It is the only major celestial object known to humans that remains in perfect synchronous rotation, with its planet showing only one face to Earth across all of recorded history. This peculiar constancy has made the near side of the moon deeply familiar, yet the far side remained unseen until the advent of space exploration. Kaku suggested that this lopsided relationship might be functional. If one were to design a surveillance system or a mechanism for directional energy focus, placing it on the hidden side of a tidally locked moon would be ideal. It could observe without ever being observed, collect data, or remain inert until triggered by specific changes in Earth's development. In this context, he introduced the possibility of dormant systems embedded within the moon. These wouldn't be systems detectable through normal imaging or spectroscopy, but rather ancient constructs, designed to awaken or react when certain thresholds are met, whether biological, technological, or environmental. Earth's progression through these thresholds could one day activate lunar processes currently invisible to us. Kaku drew analogies to genetic junk DNA in humans, vast stretches of code that appear purposeless until very specific conditions call them into action. What if the moon itself is structured similarly, its apparent silence being a form of latent potentiality? Kaku then discussed the lack of volcanic or extensive atmospheric evidence on the moon, and how this absence aligns poorly with many conventional models of planetary development. Most celestial bodies in our solar system display traces of geological dynamism, yet the moon remains largely inert. However, subtle outgassing events have been recorded, with plumes of gas briefly emerging from certain locations. These exhalations, seemingly random and unconnected to surface impacts or solar heating, may point to subterranean cavities under pressure, perhaps even sealed chambers slowly releasing their contents through microfractures. Kaku proposed a hypothesis that these gaseous events might not be geological at all, but instead remnants of past technological processes decaying over time, or purposely calibrated to emit material over vast intervals. He shifted focus briefly to lunar acoustics, specifically referring to studies involving vibrational feedback from impacts. When artificial impacts were created during the Apollo missions, such as crashing spent lunar modules into the surface, the moon rang for an extended duration. While this has often been explained through its dry, fractured internal composition, Kaku proposed that the acoustic profile of these impacts might hold clues to subsurface density variation and internal design. He suggested utilizing advanced acoustic mapping technologies, capable of penetrating several kilometers into lunar crust to identify layered echo patterns or interference waves indicative of structured materials or cavities. Moving into the realm of energy, Kaku highlighted the moon's incredible potential for solar collection, given its unfiltered exposure to sunlight for extended periods. He noted that if an advanced intelligence sought to build a passive energy harvester, the moon would be the optimal location. Solar panels or energy receptors integrated into its surface or beneath reflective regolith could remain undetected from Earth, but function efficiently in collecting and possibly redistributing energy. Kaku raised the possibility that ancient energy storage systems or power transfer technology, possibly through high-frequency beams or quantum resonance, could still exist beneath the moon's surface, now dormant or degraded. He then addressed the possibility that the moon might serve as a gravitational stabilizer by design. While the stabilizing effect of the moon on Earth's axial tilt is well documented, Kaku speculated that this could be a secondary effect of an intentional placement. Using computer simulations and gravitational modeling, he described how a moon of the current size, mass, and distance is statistically rare among known planetary systems. Yet these very parameters ensure Earth's climate stability. If a civilization capable of astroengineering existed, designing such a system would not be unthinkable. The moon, then, would be not merely a natural satellite, but a gravitational anchor, a planetary gyroscope installed with the intent of creating favorable evolutionary conditions. Please consider liking and subscribing to our channel. Also, leave your comments below and share your thoughts on the moon's true nature. What do you expect Kaku reveals? We want to hear from you. Thank you for watching and see you next time.